Okay, so today's opener is just a review of the lessons that we did last week, 7.1 and 7.2, and that you guys took a quiz over on Friday. So the first part we're going to look at is simplify each expression, okay? So we're going to look here, we're going to simplify each expression. We're going to simplify each expression by either multiplying or dividing. So if I look at this first one, am I going to multiply or divide? Look up here. Divide, yeah. So that fraction bar means to divide. Can I take my coefficients, my -4, and divide it by 12? No. But I can do something to them. What can I do to them? What can I do to this -4 over 12? What should I do to them? I'm not going to flip it because my coefficients can stay negative. I'm not worried about my exponents yet. Not yet. Remember, my negative coefficient, that -4, it can stay a negative. The only thing that can't be negative are my exponents. So that -4 is fine. But since I can't take -4 and divide it by 12, I can do something to it. Simplify it. So -4 over 12 can be simplified to what?
Multiply that by 2 will be -2 over 6.
So we have -4 over 12. You said they're both divisible by 2, and we're going to get -2 over 6. Can I reduce that or simplify that further?
Yep.
Yeah. What are they both divisible by?
2.
Okay, so I'm going to divide it by 2 again, and what am I going to get here?
1 over 3.
Don't forget about your negative. So it's going to be -1 over 3. Now I worry about my exponents. When I divide and my exponents have the same base, what do I actually do to the exponents? Yeah, so it's going to be what?
9.
W to the 9th. Okay?
Is that the answer?
That's the answer. What could I get rid of to simplify this further? What could I get rid of to simplify this answer further? What's in there that I don't necessarily need?
Well, we don't need the 3.
I do need the 3. That's a number. That's like a...
We need W.
That's my exponent base. I need the negative.
We don't need the exponent 9.
I don't... Oh my God, you guys. Do you guys really not know what I don't need here to make this in simplest form?
Dylan said a negative.
Well, if I had a -$1 million and $1 million, that's pretty important to keep, right? So we need the negative. Yeah, you don't need the 1. So you could just get rid of that 1, and then your answer here is in simplest form. Now, if you had the 1 written in your answer, that's okay too. Okay, let's take a look at the next one. So I'm looking down below here. So I have, in parentheses, 4 to the 0, c to the 2nd, d to the 3rd, f, divided by 2, c to the -4, d to the -5th, in parentheses, and it's all to the power of -3. So how am I going to start to solve this problem, Maddie? What's the first step I'm going to have to do here?
Discount your exponents.
Doing what?
I'm not good on that, the division parentheses thing.
Okay, so if I have something, well, let's take a look at it. If I have something on the outside of the parentheses here, and I have a bunch of terms on the inside of the parentheses, what am I going to do with this guy?
Distribute.
Yeah, I'm going to distribute.
So you have to like rewrite it so it's not.
Okay, so we're going to distribute. Now, 4 to the 0 power, what does that equal?
4 to 0 power 1.
1. Now, 1 to the -3rd power will be what? We don't know yet because it's a negative exponent, so we can't do anything. So I'm going to go ahead and rewrite this as 1 to the -3rd. Okay? And then I'm going to go ahead and, well, when I have power to power, do I multiply my exponents or do I add my exponents?
Multiply.
Power to power, I'm going to multiply, and I'm going to worry about my negatives in a minute. So I'm going to take c squared times -3 to get what?
-6.
Okay, and then what about my d?
-9.
And then my f.
-3.
Okay. And then whatever I distribute on the top, I also have to remember I have to come down to the bottom and distribute there as well. So each term I'm going to distribute. So how do I rewrite my 2? 2 to the what?
3rd.
What kind of third is that though?
Exponent third.
What? Positive or negative?
Negative.
Okay, negative. I'm going to worry about that negative in just a minute. Okay, c to the what?
Oh, C to the. Okay, C to 12.
And then d to the,
20.
no, look at that again,
Oh, 15.
15th. Do you guys have any questions on how Ben got those exponents? Any questions on what we did? So when you're going power to power, when you're distributing, you multiply your exponents together. Okay, now, what's the next step that you're going to do?
Cross the line.
What do you think, Maddie?
Box it.
Nope, not box it yet. Wishful thinking there, right?
Cross the line.
Cross the line to what?
The negatives on the top negative, the bottom negatives, to the.
What's the purpose of crossing line? When I cross the line,
The opposite.
I'm able to,
Make the exponent not a negative.
yeah, so when I cross the line, I'm able to change the sign. So let's go ahead and take a look at that then. So what am I all going to cross the line with here?
2 negative.
So I'm going to cross the line and bring that to the top. Okay, so that one's completed.
Put 1. Wait, okay, 4 negative 3 to the bottom.
4 negative, oh, that was a 1 negative 3, kiddo. Okay, so I brought that to the bottom. Now what?
Isn't that supposed to be 4 though?
No, because 4 to the 0th power is 1.
4 to the 0. Oh. That looks like addition.
Okay, now what?
1.
C6.
Okay, I bring that down, right? C to the 6.
Don't forget C to the 12.
That stays on the bottom though, right?
Yep.
Okay, then what?
Oh, yeah, okay. D to the 9.
Goes on the bottom, okay.
And D to the 15.
Stays on the bottom.
Yep. And F to the 3rd.
Okay,
I don't mean it.
that's a lot of work.
Now
Now what do I do?
we combine like
Okay, so when I combine like terms though, I'm not combining like terms. What am I actually doing? When these numbers and variables are touching one another, what operation is that asking you to do?
addition,
No, it's asking you to do what with them?
subtraction,
Multiply. But when I multiply bases with the same exponents, I actually do what to the exponents?
multiply them, minus.
Ben, I want you to stop.
Okay.
I want you to think before you spit out answers.
What was the question?
Because you're saying like 9 million different things all at once, okay? So stop and think about what you're going to respond. Think about what I'm asking. We need to simplify this, right?
Yep.
To simplify this, I'm going to take 2 to the 3rd power. What's 2 to the 3rd power? Is it 2 times 3? Or is it 2 times 2 times 2?
Second option.
Second option, okay? So what's 2 to the 3rd power, you guys? You should all have your calculator to type it in.
8.
So we have 8. What's 1 to the 3rd power?
1 to the 3rd power is just 1.
1 to the 3rd power is just 1. So do I really need to have that 1 in there? No, I'm not going to need to have that 1 in there because I still have all these variables down here.
Okay.
So with the variables down here, what am I going to do?
Combine C carrot top 6 with C carrot top 12.
Okay? And when you multiply those bases with the same exponents, what do you actually do to the exponents?
Times them.
Add them. Good, Emily. So it's going to be C to the what?
18.
Then we have D to the,
24.
and then F to the,
3rd.
there we go.
That's a lot. Where did you get 24?
We got 24 by taking 9 plus 15.
I just gonna read it.
Oh, yeah, sorry. Here. I just hate having all the lights off. It just makes it so dark. Is that helpful?
It's like 10 times better because I can.
Okay,
hardly
okay.
see.
All right. Okay. So when we're looking at our next problem, in parentheses, I have c to the third power. On the outside of the parentheses, another power 2 times negative 3c to the fifth, parentheses to the power of 2. So I have multi-steps that I'm going to do here. Raise your hand if you think you can tell me what to do first. Where am I going to start with this first? Ben?
Are you on the bottom one?
Yep, bottom left.
Do you have to rewrite it?
What's that?
Do you have to rewrite it since, oh wait, no, never mind, that's something else.
You're kind of right because you're going to have to do an operation to them.
So I would just times the exponents.
Okay, so so when you say you're going to times the exponents, you're going to take it power to power? Okay, so power to power here would be what?
6.
C to the
6.
6, okay. Maddie?
Do you have to distribute on both of them?
The second one, well, this one we can just do power to power, but the second one I'm going to have to distribute. Because what's this squaring?
5.
And what else?
-3.
Yeah. So then I'm going to have times, what's negative 3 to the second power?
6.
Not negative 3 times 2, but negative 3 times itself twice. So positive 9. And then remember, power to power, what do we do power to power?
Add the times exponents.
And we get,
10.
okay. Now, you've done a nice job so far. We have one more step that we're going to have to do. Anytime I have a variable by itself, what can I always envision or imagine that's up in front of that variable? A 1. So we're going to multiply our coefficients. What's 1 times 9? 9. So after you multiply your coefficients, then you multiply your exponents. But in fact, when we multiply exponents, what do we actually do with them? Add. So c to the 6th plus c to the 10th, which equals?
9c 60.
Perfect. That one was a little less complicated, huh? Well, maybe not less complicated, just less work. Questions on this side? It's not going away, you guys, okay? On your test, you want me to tell you how many you're going to have on your test of like those? You have 1, 2, 3, 4, 5. Okay? Well, kind of 8 because you're going to evaluate too. Okay, next part. Find each sum or difference. When I'm finding the sum or difference of polynomials, I first have to determine, am I going to add them or am I going to subtract them? In this particular problem, am I going to add or subtract? Subtract. How'd you know that, Maddie?
Because it shows it.
Yeah, the subtraction sign between the two groupings. When I subtract polynomials, I'm going to first do what?
Rewrite it.
Rewrite it by dropping the parentheses and then
Do it. G3 minus 2G2 is 5G plus 6.
but what do I do with my subtraction sign?
Flip them. On the
Distribute.
second one.
Yeah, I distribute it all to the second one. Good. So that's going to equal what, Maddie?
It'll be G2 minus.
How about
G,
you got to distribute that negative over, right? So it's going to be
negative G2
then what?
minus 2G.
Perfect. You got it. Okay, so I dropped my parentheses. I distributed my subtraction sign. Now, my next step is to do or to, I don't want to use the term because I want you guys to tell me.
Yeah, then you
Keep
got
the invisible exponent on there.
You want me to put it on there? Yeah, I can go ahead and put that on there. Okay, what do I do though? What's my next step?
Like term.
Combine like terms. And when I combine like terms, I want to start where?
The highest number.
The highest exponent, meaning the highest degree, which is what?
Would it be 2G because there's no other 3?
What's the highest exponent?
G3.
G3. But Maddie had a good point, but Ms. Lidekin, there's no other G3. That's okay. We're still going to put that down first because that's still part of our answer.
Oh, you told me that.
Okay?
I asked that.
Okay. So we're going to go ahead and bring that. Even though it does not have a like term to combine it with, we can't ignore it. We still have to bring it down. It's still going to be the highest degree in standard form, right? Standard form is where we write our answers in highest degree to the least degree based on our exponents. Okay? What's my next highest degree that I'm going to look at? So I'm just looking at the exponents here. What's my next highest degree? to the second power, right? So what is that term that has to the second power?
2g to the second power.
Negative 2g to the second power. And what else?
Oh, and then negative g to the second power.
Okay. So you need to look at it. You need to read it, and you need to think about what it's asking. It's saying negative 2g squared minus g squared. What's negative 2g squared minus g squared? Remember, anytime a variable is by itself, what can I put up in front of it? A 1. So it's basically asking you negative 2 minus 1 is what?
3.
Negative 3, and then what's my like term I need to bring down? G squared. Questions on that part? Okay. What are my next like terms I'm going to focus on? Okay, so what are the terms?
5g.
No, you're so very close though.
Negative 2.
Negative 2g is absolutely positively one of them, and I accept that answer because you gave me the operation sign that goes with it.
5g's.
What?
5g.
What? I mean, really picky.
Positive.
There we go. That's what I want. So we have positive 5g minus 2g. Combine your like terms. What do you end up with? 5 minus 2?
3.
So positive 3g. Okay. That's my final answer. Now, if I were to ask you, which I will on your assessment on Friday, if I were to ask you to name this to name this, what would you name it? How do you know what to name it on? What do you look at? Ben?
Notes.
The what?
Notes.
Yes, you look at your notes. I love that answer. That is the perfect answer. And then once you look at your notes, you look at what first?
You gotta count the variables and the exponents.
The exponents.
And then
So the exponents, I have 3,
terms, not variables.
4, 5, 6. And then how many terms do I have?
3.
3. So it's 6 degree.
But where's the positive 6 in then?
Oh, did I have? Ooh, Benjamin. We forgot about that guy. That's important. So that changes our number of terms, doesn't it? It doesn't change our degree, so we're still at the 6th degree. And how many terms do I have?
4.
4. So 6th degree.
Polynomial.
Yeah, nice job. So first hour, one of my kids referred, because everybody first hour is just like, ugh, because it's Monday and it's dreary and it's Monday. And he's like, it's like the Garfield effect. You guys know Garfield?
Talking about the cat.
The cat, how he hates Mondays, they're lazy. He's like, so he called today the Garfield effect. So we're going to call today the Garfield effect. So me forgetting about that positive 6, Garfield effect. Ben, the first 3 problems, you yelling out every operation just for fun, Garfield effect. Okay? Okay. Emily, what am I going to do next?
It's a real tough one. I want that Garfield stuff.
Yes, you do. Look, what's it asking you to do? You did know, didn't you? Okay, all right, just checking. So when I'm adding polynomials, the first thing that I'm going to do is what? Dylan, can you help her out? When I'm adding polynomials, what do I want to do?
Add the 60.
Well, I want to rewrite it without the parentheses, yeah. Now I realize it's been a whole weekend since we've had to look at these and do these. So if you're unsure of the steps you need to do, I would recommend that you reference towards your notes, okay? Once I drop my parentheses, my next step in order to add polynomials is to do what? So I drop my parentheses. In order to complete this, Maddie, I need to combine like terms. And what?
2c2 and positive 5c2.
Thank you for saying the positive IC2. Now, because c squared and c squared, they're the same variable with the exact same exponent, that's what makes them like terms. So go ahead and combine those, Maddie.
7c2.
Now, if you say 7c2, that's how it would be.
Oh, to the second column.
I know, it's hard because it's just easier to say, so we kind of get lazy. I know what you mean, but we have to make sure that we speak it correctly.
Round the 6 to 60.
Yeah, why do I just bring that guy on down? You're absolutely right. Why?
Because it's not combined with anything else.
Yeah. And then,
Just add the 4 with the negative.
so positive 4, negative minus 7. Positive 4 minus 7 equals?
Oh man, we didn't do that. I didn't plan.
Negative 3.
Negative 3.
Here's a good one.
Man, this computer and I are going to go round and round. It's been doing that a lot on me lately. Okay. Questions. How many degrees does this polynomial have?
Cubic.
Cubic. And how many terms?
Trinomial.
Trinomial.
Trinomial. Very good.